Hello everyone. Today we will discuss and perform experiment 3 on hardware. So we have to design and test the half adder circuit and full adder circuit using digital IC gates. Half adder circuit we know is used for addition of 2 bits, while full adder circuit is used for addition of more than 2 bits. Now half adder circuit we know we give two inputs A and B, and we get output sum and carry. So we can form the truth table like this: AB and two output sum carry 0 0. It will give sum 0 carry 0, 0 1 sum 1 carry 0, 1 0 sum 1 carry 0, and 1 1 sum 0 carry 1. So using AMAP we can simplify expressions for sum and carry. So sum is given by XORing of A and B, while carry can be given by A dot B. Now this is the circuit for half adder. A XOR B will give the sum, while A dot B will give the carry. Now coming to full adder, we will have three inputs A, B and carry in from the previous stage. It will give two outputs, sum and carry out. So we can form the truth table for this also. A0, B0, C in 0, then sum 0, carry 0, A0, B0, C in 1, so sum 1, carry 0, and so on. You can fill all the entries in this truth table. Now using K-map simplification, we got this expression for sum A XOR B XOR C in for sum, and for carry we can get carry either through this expression AB or AC in or BC in, or using this expression AB or A XOR B dot C in. This is the circuit for full adder. Two XOR gates are used to give sum, two AND gates and one OR gate is used to give C out. Now to design half and full adder circuit on hardware, we require 3 gate ICs: AND gate 74808, OR gate 7432, and XOR gate IC 7486. We need breadboard to implement the circuit, power supply, connecting wires, and LED. Earlier we have performed this experiment on virtual lab. Today we will discuss how to implement it on hardware. So this is the procedure. You have to see the data sheets of IC for pin configuration. Then you connect the +5 and ground leads of the power supply to power and ground bus strips on your breadboard. The horizontal holes which are present at the top and the bottom. So top one you can make +5 and ground one you can make 0. Place the IC on the breadboard and point all the chips in the same direction. Pin 1 at the lower left corner on the breadboard. Give +5 volt to pin 14 and ground to pin 7 of all the ICs. Now select a connection and place a piece of hook wire between corresponding pins of chip on the breadboard. Make all the connections which are required as shown in schematic diagram, and after connecting the circuit properly, switch on the power supply. Finally, observe the output for different input combinations and match it with the truth table given. So let's see how to implement it on hardware. So we have to design half adder and full adder. This circuit is for half adder and this circuit is for full adder. So you can form full adder using two half adders. Now this is the truth table. You can fill it. 7408 is for AND gate, 7432 is for OR gate, and 7486 for XOR gate. So this is the circuit for half adder. So XOR gate, for pin 1 and 2 you will give input, and 3 at 3 you will get the output. So you need one XOR IC and one AND IC to implement half adder circuit. So for AND gate you give input at 1 and 2 and you will get the output at 3. So this is the connections. So this is XOR gate, XOR IC, this is AND IC. So you will give input to XOR ICs 1 and 2, and 1 and 2 you are giving input to 1 and 2 of XOR IC, and you are getting output from third pin. Same connections you have to give, same inputs 1 and 2 you have to give to AND gate also. So you are connecting, you are giving this input, first input to this AND gate also, A or whatever you consider X, and second also you are giving to second gate. So you are shorting these. So this is shorted with this one, this is shorted with this one, and this is shorted with this one. And these 1 and 2 you are getting from switches. For the output, you are getting output this sum from third pin of XOR gate, and for carry you will get it from third pin of this AND gate AB. So you are getting it from this third pin of this AND gate. So you have made all the connections for half adder. So let's verify its truth table. So this is the circuit. These are the outputs. This is for sum and this is for carry. So 0 0 both are 0. So when we have given 0 1. So 0 1 it is glowing, sum is glowing. For 1 0 this is 1 0. For that also this sum is glowing, carry is off. Finally for 1 1 you can see sum should be 0. So for 1 1 sum is 0, the sum is 0 and the carry is glowing. So in this way we have verified the truth table for half adder. Now coming to full adder, we require 2 XOR gates, 2 AND gates and 1 OR gate. Now we know that in a single IC we can have 4 gates. So XOR we require 3 ICs only, one for XOR, one for AND and one for OR. So 2 XORs. So we are giving A, B, 2 inputs to this first XOR gate, 1, 2 and 3 we are getting output. Now this is also shorted, this 1 and this 2. These inputs are these inputs, 2 inputs you are giving to XOR, are you are also giving it to this AND. So this input which you are giving to this XOR, you are shorting it to this AND gate. Then this 3 output of this XOR gate you are giving to input of this input of next XOR gate, which is 4th pin and 5th pin, and finally 6th pin you are getting the output. Now for OR you are using 2 AND gates, so 1 and 2 you are getting output at 3, 4 and 5 you are getting output at 6. So this way you have to make all the connections. So you have made all the connections and 3 inputs you are giving. So you have to verify its truth table. So for you are giving 0 0 1, 0 0 1, sum 1, carry 0. Then 1, similarly you can verify for different combinations. And finally for 1 1 1, when all the inputs are 1, both carry and sum should be 1. So in this case, when all inputs are at logic high, sum and carry both are 1. So this way you can implement half adder and full adder circuit on hardware. So can see this is the whole circuit. 3 ICs you have taken, XOR and an OR for full adder. So this way you can verify truth tables for half adder and full adder on hardware. Thank you.